Alright guys, we're here on the last page. This should go a lot easier than the front. Obviously the front had a lot of algebra that we had to get through. This should be a lot easier. Number 9, list the sides in order from least to greatest. So we have 65, 70. We need to find angle C. Very simply, you're going to start by doing 180 minus 65 and 70. Add those together, you get 135. And that gives you 45. So 45 in there. Then, in order from least to greatest, smallest angles across from shortest side, largest angle across from longest side, and it's that simple. So, smallest angle across from shortest side, AB. Middle angle across from middle side, CB. That leaves 70, the largest angle, across from the longest side, AC. Simple as that. Number 10, the opposite kind of. List the angles in order from least to greatest. Same idea going backwards. This is my shortest side. What angle is it across from? Like I said, the one angle that's not actually part of its endpoint, that's angle R. Okay, this is the middle angle. What's it across from? The angle that's not part of its endpoint, angle S. And SR is the longest side, across from angle T, the largest angle. Okay, so pretty simple ideas there. Should not be too difficult. Okay, so let's clear that. Let's move down to problem 11. Problem 11 wants us to label this given the information. So I know it looks in a certain way, so you may think, okay, small side, middle side, large side, small angle, or medium angle, small angle, large angle. And that's probably right, but read the information, because if it's not drawn to scale, it might throw you off. This one does happen to be, so it's not too bad. Side lengths 20, 13, and 24 with the longest side at the bottom. So longest side at the bottom. Angle measure 17, 27, and 136 with the smallest angle at the right. So the smallest angle is 17. Now, using the rules we just looked at 9 and 10, if 24 is my longest side, it has to be across from the largest angle, and that puts 136 right there, and this has to be 27 by default. Well, if 17 over here is the smallest angle, it's across from the shortest side. That makes that 13 and that 20. Shouldn't be a big problem, just please understand the difference between angles and degrees in the corner and side lengths, not degrees, some sort of length unit of measure. Okay? So we'll clear that, go to the other side. What is the reasoning that proves AC is congruent to AC? When we're doing proofs, and we mark that right there, what's our reasoning when we write AC is congruent to AC? Reflexive property. Number 13, what is the reason that proves UJO is congruent to EJA? Okay, follow those letters. UJO, EJA. Notice they're meeting at J, 2 lines crossing. That makes this angle here and this angle here congruent. What is the reason for that? Vertical, that's an R. Vertical angles. Okay, and they're congruent. Alright, so let's clear the screen. Last little bit, almost done for those of you going through all these videos. So the last 3 are the following triangles congruent, if yes, why? So up here at the top, I'll remind you what your congruent shortcuts can be. They can be SSS, SAS, ASA, AAS, and HL. Okay? What they cannot be is AAA or SSA. Okay? Those do not show congruence. So, if you look here at A, and when you're doing this, you're just looking at one triangle, because both triangles, if they're congruent, should have these markings identical. But you have angle, angle, the right angle here, and then they share that side. So when you follow that, that's A, S. So that's yes, like I said, by AAS. B, they share this. But look at the way that goes. That's the angle. That's the side. That's the side. Okay? That spells the bad word, and whether it's forward or backwards, that does not show congruence. Here, we keep seeing this over and over. I know it throws you off, but the arrows indicate parallel lines, and this is a transversal. So for the two side lines, here and here are alternate interior angles. They're congruent. Then when you're looking at the top and bottom and that same transversal, it makes alternate interior here and here. So alternate interior angles are matching there, and then they share this diagonal. So I know it's a lot of stuff going on there, and I'll see if I can take it off. Probably have to take everything else off, yeah. So let me just erase it in the normal way. But the point I was getting to, all right, I don't know where the eraser went. But the point I was getting to is you have opposite alternate interior angles on both sides, and then the side in the middle, so you have angle, side, angle. That is a yes on that one. So, letter D, you see they mark the two sides, top and bottom, and the angles, and they share this. So that's side, angle, side. SAS, that's a yes. Here, very clearly, side, angle, side. Yes, SAS. And over here, we've talked about before, three possible answers to this one. Clearly, right here, it's marked SAS just off the bat. So that's one possible answer. They share the middle, so all three sides have been shown congruent. Then it's a right triangle. The hypotenuses match. Another side match. That's also HL. Okay? So I hope if you've watched any of these videos, they helped you. I know they could be a little bit long, but there's a lot to cover. And hopefully you'll do well tomorrow if you have a chance to look through these. All right, so good luck.